Okay, this will be a quick overview of the formulas that we have talked about to date. These are going to be the acceleration formulas specifically. So I'm just going to talk about each one in turn. So the first one we're going to cover is A is equal to V minus V naught over T. Okay, this is a handy little formula. So A is for acceleration. You have V, which stands for final velocity. Then we have V naught, which stands for initial velocity. Then we have T, which stands for time. All right. So this formula is a very handy formula to have if you're trying to find the acceleration. So if you're looking for the acceleration, you have final velocity, initial velocity, and time. You can always plug it in to find that. If an object starts off at rest, the initial velocity will end up being 0. So if you're looking for, let's say, let me just do this real quick example problem. Let's say that we have an object accelerating at 3 meters per second squared for 2 seconds, and you know it starts from rest. Well, if we know it starts from rest, V naught is 0. So the way you would use this formula, you can use this to solve for the final speed. Okay, so we would do 3 equals V minus 0 over 2, and we could pretty quickly find that 6 meters per second would be the final velocity of this object. All right, just a couple of, one quick little example of how to use this formula. There are a multitude of others, but just as an example for this video, that's what I'll use. Let's look at the next formula. Next one up is the position formula. Position is equal to 1/2 AT squared plus V naught T plus X naught. Now this looks like a lot, but keep in mind that a lot of the time some of these will cancel out. Not all the time, but some of the times, alright? So for instance, one of the problems we worked today, we noticed that usually there was, one of these terms would usually go away, and that's normally the case. Quite frequently, X naught will drop out. You just got to be careful every now and then it won't. Be aware that X naught is often 0, not always, but often 0. If an object starts off at rest, then V naught will go to 0. And if an object doesn't have an acceleration, then that goes to 0. All right? So that doesn't always happen, but you should just be aware that some of these terms usually drop out during the course of the problem. So let's do a quick little problem here to get this, just to show how this would work. Let's say that you have, here I'll do 2 problems to show you how this works, because it's a pretty useful formula. So let's say that we first have an object. We want to know the position of an object that starts off going 3 meters per second. So its initial velocity is 3 meters per second for 2 seconds if it has an acceleration of 2 meters per second squared. Okay, so all I've got to do if I want to find the position is just plug it in. There is no initial position, so that last term drops out. So I'm left with 1/2 times 2 squared plus 3 times 2. So I end up with X is equal to, let me put a parenthesis around that, there we go, 4 times 2, which is 8, times 1/2, which is 4, plus 3 times 2, which is 6, and so the position would be 10 meters. All right, so that's one useful thing to do. So if you're just looking for a position, that's always a good go-to problem. But what if I told you that an object went a distance of 300 meters, and it did this, it started from rest, which meant that it's got 0 meters per second, and it did this with an acceleration of 6 meters per second squared. And I want to know if it had an initial velocity of 0 and it had an acceleration of 6 meters per second squared, how long did it take to do this? Now notice, we can't use this formula here because there is no final velocity. But you don't need to find a final velocity because you have the position. So you can do 300 equals 1/2 times 6 times t squared plus 0 times t, because v naught is 0. Notice that goes away. Notice there was no x naught mentioned. If x naught's not mentioned, if there's no initial position mentioned, you can assume that it's 0. So this gives us 300 equals 3t squared. If we solve for t squared, we get 100 equals t squared. If we square root t, square root 100, we get 10 seconds equals t. So notice here we were able to solve for the time by having the position and the acceleration. All right, that's very, very important to be able to do. Next up, this formula comes in handy when you just cannot think of any way to find time. If you don't need to find time and you just can't figure it out, this is always a good formula to go to. And what this formula does is essentially allows you to solve for the other variables without time. Notice these other formulas all have time in them. So there's time there, and there's time here. All right. This one doesn't have any time, and so that's a handy thing to have. So let's just figure out, use this for the obvious purpose, to find the final velocity. So I tell you that something starts off going 3 meters per second. So it's got an initial velocity of 3 meters per second. It accelerates at 2 meters per second squared for 5 meters. What is the final velocity? All right. Notice that if we didn't have this formula, then I would somehow have to come up with time in order to find the final velocity. Because really the only other formula that we got is this one right here that's got final velocity in it. This has final velocity right here, but in order to get there, I've got to have time. And so I could use the v naught and the a and the x and use this formula, but notice then I've got all kinds of complications, because I would do 1/2 times the acceleration times time squared, but I can't cancel this term out anymore, so I would have to do a quadratic formula. And so I learned today that y'all didn't necessarily like doing quadratic formulas. So if you don't like quadratic formulas when you're trying to deal with time, try to use this. Okay, so v squared is equal to, let's see, v naught squared, which would be 3 squared, plus 2 times acceleration, which is also 2, times 5. So we do that, and we would get v squared equals 9 plus 50, or v is equal to the square root of 59. And you can plug that into your calculator if you want to. It would be, what, 7 point something? I'm not going to plug it into the calculator, but 7 point something if you wanted to plug it in and be specific. You can also use this formula if you don't have time or you don't want to worry about finding time if you're trying to find another variable. So let's say that you know that something goes 300 meters. It has an initial velocity of 0, a final velocity of 10, and you want to know what the acceleration would be. Okay. Again, you could do this using other formulas. You would just have to find time first. You want to avoid having to find time, then use this formula. If we want to know A, you've got the initial velocity, you've got the final velocity. So all you need to do is plug it in. So 10 squared equals 0 squared plus 2a times 300. So we would get 100 equals 2a times 300. Or, let's just rewrite this as 100 equals 600a. And so a would be 1/6 of a meter per second squared. All right. Last formula. Last formula is delta x over delta t equals v plus v naught over 2. And these are all equal to the average velocity. This formula is nice to have on hand just in case they ask you to find the average velocity, or if you're given the average velocity, you can make something of it. So sometimes somebody will give you the average velocity, and then you'll have a time available. If you have this formula, then you can just plug it in there and find time. I really can't think of a specific instance where you'll need this, but again, anytime you're asked to find the average velocity, it's nice to be able to have this formula. All right. If we come across one while we're doing problems, I'll make sure to point it out where this is like the advantageous formula to use. Again, this is more just another tool in your toolbook, okay? So the big three are the ones that we went over just earlier. This is just another one to have that you can use in the event that you are having trouble finding an answer with one of the other ones, all right? So these are your big four formulas, okay? You've got A is equal to V minus V naught over T. You've got X is equal to 1/2 AT squared plus V naught T plus X naught. You've got V squared equals V naught squared plus 2AX. And lastly, but not least, you've got, actually this probably is the least, you've got this one, which is delta X delta X over delta T equals V plus V naught over 2 equals the average velocity. You should keep in mind that you do not have to use all three of these at once. You can do delta X over delta T equals the average velocity. You can do V plus V naught over 2 equals the average velocity. Or you can do delta X over delta T equals V plus V naught over 2. Any of those will work, all right? You can use them all. You can use all three of them together, or you can use one of those variations of the formula. All right. This is a summary of all of the formulas that you have so far. Please allow me to help you if you have any questions or concerns.